Hello, ladies and gentlemen. This video is going to be in place of our time that we were supposed to be together on Friday 3/12. So what I'm going to do is just share my screen to start, kind of talk about some expectations that I have for the time. I kind of already discussed this in class today, Thursday 3/11. But just to kind of reiterate a couple points before we get started with the actual content. So if you go into the folder for today, you would have seen the 5-3 notes. Today we discussed characteristics of polynomials, ways to describe them, right? Talking about putting it in standard form, leading coefficients, and all that good stuff. For Friday, we're going to continue to be out of the same note packet, except we are going to be doing pages 4 and 5 of that. So make sure that you access these notes prior to finishing this video, so you can take good notes and kind of just follow along with what we need to do. All right. Towards the end of this video, I'll discuss the homework assignment. I already kind of outlined it in a message that I sent to all of us in class. So hopefully you got a chance to look at that, but I will be talking about that towards the end of this video. Okay. The notes that we're going to work out of look like this. So this is pages, like I said, 4 and 5 of that 5.3 note packet that is in the folder for today. Like I said, today we started with just categorizing. We talked about different vocabulary words that we're going to come across, ways to name certain polynomials based off of their number of terms, based off of the highest degree. We put it in standard form, and all of that's really important to us, as I reiterated in class a lot of times, to kind of understand what the graph looks like, some of the characteristics that we might see. An important piece about that is what we're kind of going to build off of today with this lesson. That was a building block lesson for us, right? And now we're going to add some more pieces to this puzzle with polynomials, all right? And we're going to talk about what's called end behavior. So just given an equation, we're going to be able to determine along that x-axis, where is my graph going, okay? And that's why it's important for us, and why I said it's a need for us to know what the leading coefficient is, whether it's positive or negative, to know what the power is and the highest power of that polynomial. So if you're having any questions about what we covered in class today, please make sure that you reach out because we're just going to continue to build off of it from here. All right. End behavior. The end behavior of a graph describes the direction of the graph to the far left and to the far right. So if we move along the negative x-axis all the way down, what's my graph going to be doing? If I move along the right axis, so all the way down in that direction, where's my graph going to be going? Where's my graph going to be ending up? Okay. In other words, it describes if the graph is going to what we're going to call negative infinity and positive infinity. All right. Now, we've definitely heard this word before, right? Infinity. We can't really place a number on it, but essentially what we're going to be able to do is say, all right, as my graph approaches negative infinity, so it goes in the negative x direction, is my graph going all the way up to positive infinity or all the way down to negative infinity in the y direction? And then we're going to do the same thing for the positive x values. So as my graph goes in the positive x direction to infinity, so if I go all the way down, is my graph going up to positive infinity or down to negative infinity? All right, that's essentially what we're going to be able to do. And the way that we do that is to just look at an equation. We're going to go through some examples, but let's take a look at some of the possible outcomes that we might have. All right. So when we're describing end behavior, right, we might have an equation like this. So 4x to the fourth plus 6x cubed minus x. All right. And what we're going to be able to do is say, as x approaches infinity, okay, that's the notation that we're going to use. So x going to infinity. So as I look at the x in this direction, where's my graph going? Notice that the graph is continuing up, and it's going to go up forever and ever. So we say as x approaches infinity, well, then y is also approaching infinity, right? As I go to the x in this direction, my y is continuously going up. If we look at x going to negative infinity, so x in this direction, where's my graph going? Well, notice that even if I go this direction, my graph is still going up, right? So all my y values are continuing to increase in that direction. So my y is still going to positive infinity, okay? And that's my end behavior. So it's always going to ask you, as I go across the x in the positive direction, where's my graph going, up or down? as I go along the x in the negative direction. Where's my x going? Up or down? Okay. And that notation that we use, a lot of times you'll hear me say approaches. So as x approaches infinity in the positive or in a negative infinity in this direction, where's my graph going to be? So that's one situation. Okay. Notice that they're both going to positive infinity. I might have a y equals negative x squared plus 2x, right? These are just some very specific examples. Notice that as I approach positive infinity in the right direction, so as x approaches positive infinity, where's my y going? Notice that it's decreasing as I move in this direction here, right? So my y is now approaching negative infinity. As I go in the opposite direction, so if I approach negative infinity, as I go across all the negative values for x, my graph is also continuing to decrease if I go in that direction. As I continue in that direction forever and ever, my y values are going to be approaching negative infinity. Okay. 2 examples. All right. So they're both increasing, they're both decreasing along the x-axis. Okay. We could run into a situation maybe where in one direction I'm doing one thing, in the other direction I'm doing another. So for example, y equals x cubed, right? Perfectly normal cubic graph, cubic polynomial. So as I'm approaching x in the positive direction, so as I continue on, notice that my graph is starting to increase, right? So as x approaches infinity in this direction, my y is also approaching infinity. It's going to increase. Whereas if I move all the way to the left, so I look at all the values on the left side of my x-axis, and it continues on in the negative direction, it approaches negative infinity, it is decreasing to negative infinity as well. That would be my end behavior for that type of equation. On the other hand, notice in this graph, if x is approaching infinity in this direction, so as I go all the way to the right, my graph is starting to decrease. So all of my y values are getting smaller, and it's going to eventually approach negative infinity. Whereas if x is approaching negative infinity, so I'm looking at all the negative x values, I continue along my x-axis, my graph is actually starting to increase in that direction, right? My y values are getting larger, so they're approaching what's called positive infinity. All right, so there's really only a couple different situations. Notice that in each of these graphs, we're always going to ask, what is x doing as it goes in the positive direction? What is x doing as it goes in the negative direction? Okay, and then we're just going to be able to determine from that what my y values are and what they're going to be approaching. All right. The way that we're going to utilize this, so how is this going to be connected to what we learned about today with leading coefficients and the degree of a polynomial and things like that? What we're going to be able to do is just look at an equation, see my dog in the background, look at an equation and be able to determine from that what the end behavior is, okay? So the first thing we're going to look at, as I said, is the degree. So what's the highest degree that I have? The degree of that polynomial. And we're going to look specifically at whether or not that degree is even or odd. All right. Because that's going to make a difference in whether or not my graph is increasing or decreasing depending on the direction that we're going there. So if the degree of the polynomial is even or odd, we're going to take a look at that. That's going to help us determine what the end behavior is. The next thing we're going to look at is the sign. So positive or negative of the coefficient. So that leading coefficient, essentially what's called the number in front of the highest term. Okay. And this chart down here is going to be really useful for us to be able to determine end behavior. So if we look at the degree and it is even, so x squared, x to the fourth, x to the sixth, whatever our polynomial gives us, if it's even and the leading coefficient is positive, an example that we would have is like this one here. My graph is continuing up in both directions, right? So it's approaching infinity in the y direction for both x going to positive infinity and x going to negative infinity. Perfect example is this one right here, right? My exponent is even, my leading coefficient is positive, they're both going up, okay? If I have a even exponent and a negative leading coefficient, they're both going to go down in the y direction. An example would be like number 2 here. My exponent's even, my leading coefficient's negative, so they're both going to go in the negative direction for my y values, right? It's going to be the same for any equation that we see. That's always going to be true. If my exponent is odd and my leading coefficient's positive, well, that's a situation where as I go to the negative direction, my graph's going down. Positive x direction, my graph's going up. So you see in this equation here, I have an odd exponent of 3 and a positive leading coefficient. Well, as I approach negative infinity, my graph's going down. As I approach positive infinity, my graph's going up. That's exactly what this chart is telling me. If I have an odd exponent and my leading coefficient is negative, that's a situation where my graph's going up or to positive infinity when I'm in the negative direction, down to negative infinity when I'm in the positive x direction, all right? And we're going to utilize this graph, and we're going to talk about this a little bit more on the next page as we go through some examples. So what we're going to be able to do, our objective is to be able to just look at an equation, determine whether or not the end behavior is going up or down, some combination of the two, and we're going to hopefully solidify this aspect for us, okay? So a couple examples that we are going to look at, all right? First things first, we always want to make sure, as we talked about today in class, that we combine any like terms, we write our equation to our polynomial or our expression in standard form, all right? So this first example here, we'll go through a couple. I have y equals 5x cubed minus 2x squared plus 1. The first thing we want to be able to do is determine the degree of the polynomial. And then if the leading coefficient or the sign is positive or negative, all right? Well, as I'm looking at this, the degree, the highest degree that I see is 5x cubed, so it's of degree 3, right? So I know that that's odd. My sign in front of that highest exponent, so it's always going to be the sign of the leading term, that highest exponent. I have a positive 5, so my sign is positive. And I'm going to go to my chart now. And this is a chart that I would suggest that you take a picture of, right? It's going to help you moving forward on homework assignments, on a test or quiz. I'm going to allow you to kind of utilize this to help you understand end behavior. All right. Well, if I look at this first example, I have an odd degree and a positive leading coefficient. So I'm going to take a look. I have an odd degree. My sign of that leading coefficient is positive. So that means that as x approaches infinity, my y is also approaching infinity, okay? So this is how you would write your answer. As x approaches infinity, y approaches infinity. As x approaches negative infinity, my y is also approaching negative infinity, okay? So essentially what this graph would look like here, for example 1, as x approaches infinity, I'm going up. As y approaches negative, or x is approaching negative infinity, my y is going down. So that's what the graph of this would look like, okay? Let's take a look at maybe example 3. We'll pop over to example 3. The reason I want to take a look at this is, first off, it's not written in standard form, right? I want to write it in descending order based off of exponent. So I'm going to rewrite this as y is equal to, my highest exponent's at x squared, I have a negative x squared, followed by a plus x, followed by a plus 10, okay? So negative x squared plus x plus 10. I determine my degree. Well, my highest degree, the degree of this polynomial is 2, which is even, right? It has an even degree. Then I want to determine the sign of the coefficient in front of that leading term, well, notice that I have a -1. So I have an even degree with a negative sign in front. So I go to my chart, even degree, negative sign. This here is my answer. As x approaches infinity, so it's going in the positive direction, my graph is decreasing. As x approaches negative infinity, my graph is also decreasing. So how you would express your answer is exactly that, right? As x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. So it's continuously decreasing regardless of where I look at this graph, right? If we were to take a look at this graph, it would look something like this. We saw this on the first page, okay? So a negative leading coefficient, even degree, decreasing in both directions, okay? Let's take a look at one more example. Why don't we take a look at example 4 here, okay? Hopefully we have a good understanding of what this is. Essentially, the biggest part is to be able to understand this chart, right? Even exponent, the highest exponent's 2, 4, 6, 8, so on and so forth. And it's positive. This is what we're working with. Even and negative, they're decreasing. Odd and positive kind of looks like it's going down in the negative direction, up in the positive direction, and then vice versa when we have a negative exponent, okay? So let's take a look at example 4. Again, a situation where we need to rewrite this in standard form. I have y equals 3x squared plus 9 minus x cubed. Well, I want to be able to write this as y equals negative x cubed plus 3x squared plus 9. My degree of this polynomial, the highest exponent that I see, is 3. 3 is an odd number, okay? My leading coefficient, so the sign of that coefficient, I have a -1 out in front of that x cubed, so it's going to be negative. Go to my chart, odd exponent, negative number. And just by looking at this graph, I'm able to determine that as x approaches positive infinity, y is approaching negative infinity. As x approaches negative infinity, y is approaching positive infinity. Okay, so what this graph would look like if you were to draw this out and kind of have a sketch, this is what that would mean. So as x approaches positive infinity, as I continue in this direction, it's going down. As I continue in this direction, it's going up. All right, like I said, utilize this chart, take a picture of it now if you need to, whatever you need to do to be able to kind of justify and help you understand. The evens are pretty easy, right? If there's a negative sign, it's both going down. If it's a positive sign, they're both going up. The odds are flip-flopped, right? So one's always going down, one's going up. It depends on the sign in front of the highest exponent there, okay? We will do more practice with this. We'll review a little bit as the week progresses, we continue into next week. Definitely kind of go over the homework, make sure we take a look at that. And that's what I'm going to lead into now, is explaining what your assignment is for the weekend, okay? So if you go into today's folder, so 3/12, you'll see there that you are supposed to do page 327, numbers 35 through 40 all, okay? So let's take a look at this just so we're aware of what that assignment is. We're going to do, for each graph, describe the end behavior and determine whether it represents an odd degree or an even degree, all right? So essentially what you're going to do is say, as x approaches positive infinity, in this example, we can do 35 together. As x approaches positive infinity, it's clearly increasing, right? So it's also approaching, the y is approaching positive infinity. As I move along the negative x, so as x approaches negative infinity, y is also approaching infinity. Well, that would mean that it would be an even function, right? So kind of utilize that chart and help you kind of determine everything. You do not have to worry about part C there, so don't worry about determining the number of real zeros. Essentially what that means is how many times is it across the x-axis, which we had already covered when we talked about quadratic equations and stuff like that. But for each of these, you should be able to determine end behavior, and then from that determine whether the function is even or odd. So just worry about parts A and B. We're going to go over all of this on Monday. We are definitely going to review this before we take our next assessment, and make sure that if you have any questions based off of this, that you come to me during office hours tomorrow morning. Remember, I have them from 8:30 to 9:30, or you just reach out over the weekend with any messages or anything, email, or however you need to reach me. I will be there to help you out along the way. Okay. Make sure you get this assignment done for Monday. We will go over that, as well as Thursday night's assignment, which was on categorizing and understanding different polynomials, leading coefficients, and the power of that polynomial.